you ever played the game AI Dungeon or talked to an online psychologist before? If you've played, then good for you because it's an interesting game. And if you've talked to an online AI psychologist, then you should probably go talk to a real one. Both of these are applications of artificial intelligence chatbots, and I built a model similar to them, although perhaps a little less complicated. Models like gated recurrent units can process sequential data like text very well, as they can choose what to remember and what to forget. They can also adjust their amount of layers depending on the length of the text, and understand the conception of time and direction. I trained the model on movie dialogue, so it makes sense to use sequential models to deal with the text. The model I used had an Encoder-Decoder architecture. For training, the input is a sentence from a movie, and the target output is the response from another character. The purpose of the encoder is to capture the meaning of the input, and the purpose of the decoder is to transform it into the response. Firstly, a word embedding layer converts each word of the input into a vector. The sequence is then fed into a possibly bidirectional encoder GRU, one word vector at a time. After the last word is given to the encoder GRU, the cell state and the output is given to the decoder. The cell state and output are a vector representation of the sentence the GRU just saw. The decoder uses an attention mechanism to help it decode the input and transform it into a possible reply. For this to work, it is given the last time steps output along with each of the encoder GRU's outputs. The attention layer, using the last time steps output and the encoder GRU's outputs, decide which encoder output is the most relevant to the current decision. If the input has the words, "What time is it?" time might have a high relevance to the word "o'clock" in the output. The decoder creates a context vector, containing primarily the most relevant encoder output. The decoder GRU uses the context vector, along with the previous time steps outputs and the cell state, to form its own output and cell state, and the process repeats. Lastly, we convert the decoder's outputs back into words using a softmax layer. Here's the final result. Hello, hello. Who are you? I'm the creator. Where are we? The library. The library? Yes. I still don't know who you are. I know. Can we leave? I can't. I'm leaving. Yes. Goodbye forever. Goodbye. In conclusion, the model was able to make some pretty good responses, although it still was lacking in some subtleties and cannot remember previous parts of the conversation. The next step to improving this would be to give it a memory and training it on real conversations instead of movie dialogue. Also, training it for a longer period of time would probably help. Nevertheless, it still produces some really impressive results.